Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, everyone, and welcome back to another exciting edition of IT Pro TV. I'm your host, Vaughn Smith, and this is our Cisco Cloud Fundamentals series. And this episode, we're going to take a look at SAN and NAS concepts. And here to help us yet again is Mr. Ronnie Wong. How are you today?
I am doing well, Vaughn. Thank you again for joining me as we continue on in our Cisco Cloud Fundamentals here. It is, of course, that time where we need to talk a little bit about the idea of NASs and SANs, right? So these are not brand new concepts to most of us that we've actually been working in networking at any point. It's about those storage appliances that we tend to use. So we're actually going over some basic terminology again, just as a reminder, because we need to actually understand those basics. And then in another episode, we're going to talk about the actual specific technology that Cisco wants you to know about. So these are the general concepts itself. So it shouldn't be a very long episode at all, but it is just a reminder. And the reason why is terminology is going to be very important on the exam. And so we want to make sure that we cover that for you. And if all this actually sounds fairly familiar to you, then yes, you're spot on. You are ready to go as it comes for the exam, especially in this area.
And there's nothing wrong with a little reinforcement of like, oh yeah, I do already know that. Because every once in a while, especially if you haven't done it for a long time, you might need to revisit the concept. So it's always good for reinforcement.
Yeah, there's no doubt, because as we get into it, especially when it comes down to preparing for the exam, right, concepts get a little bit more muddled. So for example, Vaughn, right now, we've talked about so many different things that are so similar, but they're different at the same time, right? So for example, we've talked about virtualization, right? We've talked about type 1 and type 2 hypervisors. Well, it might be at this point where I haven't mentioned in a long time, and now you're saying, what is the difference between a type 1 and a type 2 hypervisor? So if that is now scaring you, because sometimes it can, you're in the middle of something, you go, oh, I know all these differences, and then they ask you something very basic, and you go, yeah, oh, which one was which? Well, that's what we want to do. We want to make sure that we can actually distinguish between these in terms of NASs and SANs and the concepts that we need to know and understand what's actually going to be involved here, okay? So when we get started and we start talking about the idea of describing some of these concepts, we're going to just kind of separate them out fairly quickly here. We're going to talk about the basic SAN storage concepts is what we're going to do. And let's begin by just trying to mention some terminology that we ran across when we first started talking about SCSI. So we talked about block storage access. Let's go to my diagram here, and this is what we want to focus in on. Okay, now I've just duplicated this from something else that we're about to talk about, but notice some of this terminology, Vaughn. Now you and I, we might actually say, all right, in terms of just a regular computer, that would be a server or a PC of some sort. Okay, I just drew a server instead. But this is the idea, is that it's a device that essentially uses that storage, right? Each one of these would represent something like a hard drive, okay, is what we would actually think about. But in the realm of storage devices, okay, Vaughn, those are not called either one, especially when it comes down to things like SANs, okay? So the storage area networks, they don't call them individual disks. They can, but what they tend to call them, of course, is these terms that I have highlighted over here. So for example, Vaughn, notice this term up here in the upper left-hand corner, which is the term initiator, okay? So yes, in storage appliances, when you talk about what needs to happen, you need to understand that there's a couple of different things that we're talking about here, and this is the idea of what we call an initiator, and that's what we want to talk about first.
Would that be similar to like a node? Okay, this is something that is initiating storage.
Right. Yeah, that's exactly right. So it's essentially an end user device or an endpoint device, whatever is actually requesting access to the devices here. But essentially, we actually also understand this from the SCSI realm, is where we actually first initiated it, is where we saw this terminology. But in the realm of just all types of SANs, you may also hear that term as well. Initiators are essentially whoever needs access to these devices, okay? So within a single SAN, right, a storage area appliance, remember that when we talked about the idea of a SAN, a lot of times it's an enclosure, a chassis of some sort, and it gives you the ability to have multiple hard drives. So not like a regular desktop computer where you might be able to slide in 3 or 4 different hard drives. These, you can actually slide in a ton of them. For example, Vaughn, we actually do have one of these devices, and it actually holds 32 hard drives, okay? So yes, if you actually think about it, 32 hard drives is what that one actually holds here. So for most of you out there, if you're working like 32, what a kind of puny weakling sized device that you have. but for us, it's actually fairly large.
Is that our QNAP?
Hmm.
Is that what we call it? I mean,
Yeah.
that's the terminology I hear. To me, I'm just like, oh, it's the place where all of our stuff is stored.
Yeah. Yeah, essentially, it's basically the QNAP. So the NAS and SANs, that's what we end up calling it here. Okay. So for us here, the term though that we're actually talking about, especially in SANs, is that idea of initiator and then the idea of the target. Remember that when we look at the idea of the target, these are really the drives themselves. Okay. So those are the concepts that we want to make sure that we understand right away. Now, Vaughn, once we do that, we are not done yet with this idea of actually understanding how it works within SANs. We can take essentially that entire volume of storage that we have access to. So here, for example, Vaughn, I have 3 separate disks inside of that SAN. Okay. Well, I can isolate if I chose to. Now, here I isolated it a little bit weirdly here. Okay, is I can actually create essentially what we call a zone. A zone allows me to take different clients if I choose to, and be able to actually say you're only accessing this particular portion of the drive, and another client is only accessing this portion of the drive. Another client is only accessing this portion of the drive if we want to.
Terminology that I would think of partitioning.
Yep.
It's a partition,
Sure.
but we're talking then in this case, there's zones.
Right. They're called zoning. Yeah, zoning. So that way it means that, Vaughn, if I put you on one zone, you're not going to be able to actually get access to another zone as well. Now, that's not the only term for that, Vaughn. We're actually going to get into something in just a moment here when we start talking about the idea of vSANs in a moment. I always want to go to VLANs because they actually operate fairly similar, but where we actually talk about that too, and this is the same idea, okay? So make sure you can distinguish the term initiator and target. Understand this. Now, here's a typical setup though, Vaughn, okay? Once we start getting into the realm of how we start identifying these components together, okay? So we could actually do something like this where I have a single initiator, but it can also access multiple targets as well, okay? So you may have a particular SAN configuration where it's set up like that, where you have what you call a single initiator, okay, but with multiple targets. And so something like that can occur where it can be that way. Traditionally, a lot of times, though, you really do have end devices really only accessing 1, possibly 2 different targets, but usually just isolated into their particular space. When it comes to cloud, that's all we want, right? We don't want a tenant being able to access somebody else's storage, so we tend to isolate it in that way as well, okay? But this is basic terminology, like I said, that we at least want to know as well. If you're saying, hey, this comes from the SCSI realm, doesn't it? Exactly, okay? So they didn't change the terminology. They essentially just used that same terminology and carried it into the realm of SANs is what they've done, okay? All right, so let's go ahead and also talk about that concept of vSAN. And this one, Vaughn, is a little bit more, at least networking analogous to something that we call like VLANs as well. Okay, at least that's the way that I first started thinking about it when I was trying to make sure that I understood all the technology here. So Vaughn, I have a network topology that you see right in front of you. Over on the left-hand side, I have different switches, and these switches can be set up differently, okay, as well, where these particular switches, this is probably in the Cisco Nexus 9000 series, that allow us to actually be able to create what we call vSANs, which is the virtual storage area network, okay, is what it actually allows us to be able to do. Now, what I can do is I can take a single Nexus 9000 series switch here, and then we can attach different appliances to them, okay, such as our SAN, and isolate them into a particular vSAN if I chose to, okay. I can actually take my servers and isolate them into another vSAN. I can take my end users and isolate them into another vSAN if I wanted to, but that's not how we normally do it. Vaughn, instead, what we try and do with vSANs is not the same as a VLAN, which is probably the more familiar term that you and I are familiar with, which essentially is creating different subnets for these. But Vaughn, what I've done is I've tried to highlight where we were going vertical instead. I have a portion of that SAN that I'm assigning to a vSAN. I have a certain number of servers that I'm assigning to a single vSAN. I then have endpoints or end user devices that are also assigned to that one vSAN as well. So I can create that across these 3 switches, and now these vSANs are isolated from one another. So Vaughn, I just kind of took the analogy to what we do like right here at IT Pro TV, right? So let's say that we have a vSAN for production. And that means when they actually store all the files, so like, for example, like what we're doing right now, when this is done, it will end up getting, again, turned into a file. Then it will go to a SAN, okay? And what that actually means is that if we actually have it something like this, where we're actually storing the information onto that SAN itself, well, that's not going to actually get stored in the same locations where marketing would store their information, or in the same place where we would actually store our stuff. So we might have that separated out in that particular fashion that way. And that way they're isolated between each other if we chose to. Okay. And I want us to pay attention to this because this is a concept that sounds very analogous to the concept of a VLAN, but it's not based on IP addresses. It's based on the technology. So for example, Vaughn, I actually typed out a sample configuration over here on the right-hand side, and you can't run this on every single switch. You can't even run this on some of the Nexus 9000 switches. If you're actually going to run this, it has to be on switches that have vSAN capabilities or are actually vSAN capable. And that means you might have to have a licensing upgrade to be able to do so. So when you do open up like a Nexus 9000 series switch, if you can type in the word vSAN, okay, and it actually accepts it as a command, well, then you're ready to go. If you type it in and it's not ready, there's one of two possibilities here, Vaughn, in that Nexus 9000. It either can't take the command because it's not actually enabled to do so, or in other words, I don't have the licensing to do so, or I don't have the right series of my Nexus 9000 switch, okay? So if I can type that in, the way that we initiate the idea of bringing vSANs online is that we first create a vSAN database, and then we assign a vSAN number and then a name to that number if we want to. And once we do that, now in that switch, we actually can say in vSAN 2, we're going to actually put in the interface, and this is fiber channel 1/9. So we can take any of these interfaces. It doesn't matter what the interface number is. But as an example, we're using fiber channel, Vaughn, for a configuration. We actually say in vSAN 2, this interface is in this. And you can actually do a different one for each of the ports here, depending on what you want to be inside of vSAN 2. Okay? And that's important because that's the way that you know that they're actually connecting correctly. So all of these devices, let's say right here, these would be in vSAN 2 with the vSAN name of prod for production, okay, is what we'd have. This one in the center would be one for marketing. The one over here on the right would be one for SME, okay, is what we would actually see. So those would actually change right there. And then we would actually take each of those switches and include whatever the actual port numbers that want to from end user devices on this one, from servers on this one, and from the actual appliances over here on this one or the single appliance, and then make sure that we actually have them separated off here in terms of fiber channel in the way that we want. So that's how we can also make sure that we do that too. So Vaughn, this is a configuration that doesn't require us to really have to have multiple switches to be able to do it. But here with the Nexus 9000, it's actually easier to be able to do so. So remember, you're not going to be able to do this on every single one, but there's actually a problem. Normally it's because we forget to add in the name of the vSAN, or we actually forget to add in the interface that's supposed to be in that vSAN, okay? So if you actually find out that you're not able to access, let's say, that storage, and you do see a vSAN configuration on there, make sure that vSAN database has been configured. Make sure you do see the proper number of vSAN here, okay? And then that you have interfaces assigned that vSAN to associate them together, okay? Very important element as you actually configure something like vSANs. Now, if you're actually saying, well, Ronnie, why don't you actually bring up a 9000 switch to do so? Because they are expensive, Vaughn, okay? They are more expensive than what I can actually afford to bring up. So here I'm just showing you a basic configuration.
And I don't know if it's because I've taken so many tests or anything like that. As you're just going through there, like the scenarios of like, oh, make sure you have the database determined before you move on, or the names. Even though I'm not as familiar with everything you're talking about, it was like, oh wait, those sounds like test questions or possible scenarios that they could ask you about. So understanding these concepts and those little gotchas as to why things might not be working.
Right.
Things to pay attention to.
Yeah, and that's kind of the key here, right? Is to understand that with the cloud fundamentals, they won't get super in-depth as far as something like this because it requires a bit more configuration, and this is more administrative than anything. But I can't tell you that they'll leave it off either, okay? So you're not going to get something that's in-depth, but the basics here in terms of vSAN, since they asked about it, would be for you to be able to identify like what elements make a vSAN work.
Yeah, and it could be on any of the concepts that you've gone over throughout this entire series. I always kind of feel sometimes when you say certain words, certain ways, I'm like, ooh, I should pay attention because that's something that they could do a scenario for me to say, like, why isn't this working?
Hmm.
And then they list off their different questions. Again,
Yeah.
I have not taken the exam, but
Yeah.
it's enough of experience in test taking.
Right. And there's a couple of other concepts that we want to make sure that we understand too. As someone that's actually going to be more towards cloud administration, you want to make sure you understand some of the features that are available when you start implementing vSANs and why they're important. Okay. So notice that right here, Vaughn, even though I have multiple vSANs, and you can see it by by the rectangles that I've drawn around the columns here, okay, on the diagram. Well, you can see that I've actually created multiple vSANs, but Vaughn, I didn't change any of the physical infrastructure. So there's still the same 3 switches I have, and even the cabling there is almost identical as well. Okay, so I have the same particular idea here that I can actually create multiple vSANs over the same physical infrastructure. Also, if we're actually using fiber channel IDs, remember, Vaughn, we talked about this a little bit in our fiber channel over Ethernet, that we can identify the idea of these fiber channel types of ports by using 2 identifiers. There's actually the worldwide names, right? The uh, WWN, which is what that one stands for, and then the FCID. Those are how we identify essentially the fiber channel types of connections that we make as well. And when we start taking a look at the idea here of what ends up happening is that on the fiber channel IDs, well, I can actually assign the same fiber channel IDs to every single VLAN, okay? So in other words, I can isolate them. So even though they're exact same fiber channel ID, they are actually going to be isolated even as long as they're actually in different vSANs, okay? So that way we don't have to actually worry, do I have a separate FCID, I'm going to say VCID, FCID or not? As long as they're separated, it actually helps us out, okay? The reason why that's good is because it means that I don't have to change my configuration too much. I can continue to grow this network and add in more and more vSANs and still have that connection that I need as well, okay? Also, every instance of vSAN that we end up running in a topology like this here, okay, all requires essentially the same types of protocols to be run as well, okay? There is what we call fiber channel single shortest path first, okay, which is essentially the path in which the data actually takes place, okay? Also, we can have domain managers that allow us to make sure that we understand how everything is actually working together as well. And then, of course, the idea of zoning. Now, why is this important? Because essentially these idea of the vSANs kind of equate to the idea of zoning as well. Okay? So they're isolating it off. They're actually putting things individually in the way that want to. And this means that it isolates a couple of things, Vaughn. I can now actually have one vSAN run and the other vSAN may not be able to run or something happens to it. It doesn't affect the other one. So it isolates problems that we may have as well. Okay. And configuration issues also tend to be isolated to a single vSAN. You name it, disruptions to a single device within a vSAN doesn't actually interrupt another vSAN as well. Okay, so the idea of actually why you would choose to run a vSAN, especially in a network that you know that's relatively stable, those are some of the features that you should actually think about too. Okay, so a little bit more detail in terms of the term vSAN, because this is the first time we've actually encountered this term, at least in our series. Okay, just make sure that you understand that, yeah, there's that possibility where what you're actually asked is, hey, what element would actually fit best in this type of scenario? Okay, I can't tell you that that's what you'll see on the exam, Vaughn, because that would be cheating, and I can't even tell you that that's exactly what they're going to ask you. But I can say that if you're looking for the ideas of scalability, okay, and self-containment and limited amount of disruptions using Nexus 9000s here, well, what do you want to consider? It might be something like, oh, vSANs, okay? Something like that would actually be a reason why you would choose a vSAN technology instead of VLANs, okay? So, you know, again, just trying to work that in so that you understand that too, okay? So all those advantages here, and the last advantage that I want to talk about here, okay, is the idea of on a single type of switch that you can actually run vSANs on, you can create up to 256 vSANs, okay? Now, in comparison to VLANs, it's not a lot, but in vSANs, though, it is quite a bit of vSANs. So just realize that that's kind of the big one here. The main appliance that you and I are going to focus in on if we're asked to create vSANs, Nexus 9000 series, okay? So just plant that into your mind for right now. Why? Because, Vaughn, there's Nexus 1000 Vs. There's Nexus 3000. There's Nexus 5000. There's Nexus 7000, 7700s. And then there, of course, are the Nexus 9000. There's actually 9500s and 9300s and 9200, whatever else that there may be. You name it, there's just so many of them. But at least in your mind right now, just realize vSAN, Nexus 9000, at least in that range. And then, you'll focus in on what you actually need to. But don't mistake that for something else, okay? In other words, don't just say, I can run that on any particular switch I want to. You got to remember, it's going to be a Nexus 9000 type of switch that you're really going to be focusing in on, okay? So that's probably more of a hint than I probably should have actually done or anything, but you kind of get the idea, okay? So that's what we want to focus in on as well. All right, Vaughn, the last particular term in terms of SAN technologies that I want to talk about, and like I said, we won't hit on the NAS too much and very heavily here because we've already covered it a little bit, but we want to talk about the idea of LUNs, L-U-N, okay? Stands for Logical Unit Number, okay? So let's take a look here as well, okay? So we're going back to the same drawing that I've actually done before, the same diagram that I created before, and you can see that this is an entire SCSI bus that we have coming across here. So remember that this is an identifier to a logical or physical device, and here, when we talk about LUN accessibility, okay, we're not really changing much overall, except that there are some changes here, okay? This technology, even though it was actually introduced with the idea of SCSI, which is the one that we first talked about here, okay? This terminology has carried over, and accessibility is key, okay? So what we want to do is actually understand that when we start talking about LUNs, it doesn't really matter in terms of the underlying technology a lot. It began with SCSI, but when you start talking about LUN accessibility, well, you can create LUNs across fiber channels. So Vaughn, here I have it in just these two fiber channel topologies in this sense, okay? So I can actually have LUN 1 actually be across these SAN devices if I wanted to, okay? If I have that point-to-point connection, I can create the same LUN over here as well. So it doesn't matter whether it's actually the point-to-point or the arbitrated loop or even the other one, which is the switched fabric. LUNs can be created across them, as well as in the idea here of SCSI is what we talked about as well, okay? Now, the other one that we really didn't spend a lot of time on, but I did mention, is the idea of iSCSI. It can actually even be considered an iSCSI as well. So the terminology actually fits across all of them. Whether we're talking about iSCSI, whether we're talking about fiber channel or regular SCSI technology, LUNs essentially come across all of them. And remember that an analogy, right? If you actually wanted to use something like RAID, it's the same idea as striping, essentially, is what it does for us, okay? It creates a stripe of the amount of data that we normally need access to or that we can isolate to. So Vaughn, when it comes down to iSCSI, instead of using the fiber channel technology itself and using layer 2 and everything else that it actually does, iSCSI, its transport is dependent on IP addresses, okay? So notice now each of these can be IP addresses, and the way that we access also our SAN via IP, okay? Or via IP, however you want to say it. It's perfectly fine with me. So here would be the same idea, okay, is that this is the way. So whether we're over IP, whether we're over fiber channel, whether we're using the SCSI technology and, of course, the SCSI bus to make sure that everything ends up working here, okay, it allows us that connection and that particular ability to create the LUNs that we need to, all right? So that's kind of the key when we start taking a look at that idea of understanding LUNs, okay? All right, so that leads us to some of the technology that we want to talk about just briefly here, and I'll mention it because we did cover it in another episode already. I want to talk about basic NAS storage concepts, okay? So Vaughn, remember the big difference between the idea of block storage and file storage, okay? So remember that block storage concepts for you and me, okay? If we are to access block storage to the end user and on the computer, it looks like a hard drive, okay? So it's not necessarily anything else, but it just looks like, oh, look, there's space available to us. That would be what we call block storage, okay? But file storage, though, means that we can connect to it, and what you and I see are individual files, okay? So that's the real big difference between them, okay, when we start to do something like this. Now, the other thing that's also, of course, different is the way that we access them. So, Vaughn, we've just talked about some of the different ways we can access block storage, right? We talked about using LUNs, we talked about vSANs a little bit, initiator, target, you name it. Those are also ways that we access block storage, and there's probably even more that's out there. Fiber channel, you name it, they actually give you that access as well. But when it comes down to file storage itself and NASs, okay, The way that you and I have to access this is that we start with our end user device and we create what we call a mount point onto that device as well. Okay. So this allows us to essentially make a connection to that device, allows us to mount that folder or drive. And now it looks like it's actually attached to my machine directly is what it does, even if it's actually a remote location. So that's the idea, is that we create what we call shares or mount points to be able to do what we actually need to do. The second idea behind this as well is that when you start accessing this too, you want to be able to control access. From the NAS, though, what we want to be able to understand is that we set up permissions. If you're not in one of those groups that's permitted to access that share, Vaughn, it means you don't get access to that share. So unlike the idea of block storage where you're accessing the entire hard drive, okay, well, as files go, we can actually make it where Vaughn is able to access a folder if we want to, but I'm not able to access that folder, okay? Whereas on the hard drive, Vaughn, I may get access to the hard drive, but I may not be able to read or, access anything in that particular drive as well. So those are some of the ones. Now, we already went over file permissions, Vaughn, and we went over the idea of file systems. Remember that for NASs, okay? Very key for us, right, is understanding that there is NFS for a file system or SMB or CIFS, okay? Those are kind of the network file systems that are actually out there for us. And also the idea of permissions is pretty key too, okay? So most of the file systems that are based on Linux and Unix in that sense, read, write, and execute types of permissions. Most of the time, I'm not going to say it doesn't happen ever, but in terms of NASs, they're usually that way. But if you happen to bring up one that's a Windows-based one, then you have to choose between those file systems as well, which is FAT, which we did go over like what we said, okay, and of course NTFS. The recommendation today by Windows is that you use NTFS unless you have a good reason not to use NTFS, okay, because that gives you all the advantages that we talked about in a previous episode, but the permissions are so granular in what you can do with them. It is amazing, okay? So just kind of realize that you have even more granular levels of permissions than just read, write, and execute, okay? So that is the whole goal. It's all about access control and what you can access and what you don't have to access, but all that actually comes together when we start talking about these basic concepts here, okay? So Vaughn, that is going to end our brief review on these, on the NAS and SANS concept, or SAN and NAS concepts, depending on how I actually put it in to the title there. But that should end our review, and that means that we actually do have to take a look at now some different hardware components. And this is where it gets a little bit trickier because it means that we have to dive into the components themselves and be able to distinguish them from some of the other components that are also out there as well. So Vaughn, that will kind of slow us down a little bit, but hopefully not too much, because we've still got a couple of episodes to go before we wrap up this entire series.
All right. Well, lots of great concepts there, and I'm doing a little supplemental research as you're talking about this, and I'm actually think I'm getting the difference between block level and file level storage. So
Great.
thank you, Ronnie.
There you
I'm
go.
learning. So I hope you're learning too. But we're gonna go ahead and sign off for IT Pro TV. I've been your host, Vaughn Smith.
And I'm Ronnie Wong.
We'll see you soon.
Thank you for watching IT Pro TV.